Today's notes are on rate of change again. Remember, rate of change is just a fancy word for slope, and we're going to use this formula. All of these questions are old Regents exams questions. We aren't going to do all of them. We're going to pick and choose the ones because a lot of them are pretty similar. They like to ask the same exact types of questions on rate of change over and over again on the Regents exam. We're going to look at number 1. It says, the Jamison family kept a log of the distance they traveled during a trip, as represented by the graph below. So these are the hours that have passed and the distance they have traveled. During which interval was the average speed the greatest? So we have to find all of the different ones to know which one was the greatest. Luckily, it's multiple choice, so we don't have to find every single one. Just do the ones they're asking about in the multiple choice. So the first one asks for the first to the second hour. So I'm going to write my points down here, 140 and 2 110. And I'm going to label them x1, y1, x2, y2. So I'm going to do my math over here. I'm not going to list out my formula because it's up here and I want to save a little bit of room. So y2 minus y1 over x2 minus x1. 110 minus 40 is 70. You could check on your calculator. 2 minus 1 is 1. So the rate of change here is 70. For number 2, it's the second to the fourth hour. Again, I'm going to write them out. So 2 and 110, 4 and 180. I already have them labeled up here, the x2 and the y2, so I don't have to rewrite them every time. So my y2 is 180, my y1 is 110, my x2 is 4, my x1 is 2, 180 minus 110 is 70, 4 minus 2 is 2. If you do 70 divided by 2, you get 35. So being multiple choice, they want to know which one's the greatest. I can cross number 2 off because 35 is not bigger than 70. Next, they actually ask for the 6th to the 8th hour. So 6 and 230, 8 and 350. So if I write out my formula, y2 minus y1 over x2 minus x1 mix. So 350 minus 230 is 120. 8 minus 6 is 2. 120 divided by 2 is 60. So again, 60 is not bigger than 70, so I can cross choice 3 out. And last one we have to do is the 8th to the 10th hour. So 8 and 350 and 10 and 390. 390 minus 350 over 10 minus 8. You get 40 over 2, which gives us 20, so it can't be choice 4, it has to be choice 1. We're going to skip number 2 because number 2 is exactly the same, except it asks for the slowest rate of change. So the slowest rate of change in that one would be whichever one is the smallest number. Again, all the work is in the filled-in copy of notes when you look at it. Number 3. Number 3 says, Joey enlarged a 3-inch by 5-inch photograph on a copy machine. He enlarged it 4 times. The table below shows the area of the photograph after each enlargement. So here's our table, enlargement. So this is the original size, and then 1, 2, 3, 4, and the area of the photograph. What is the average rate of change of the area from the original to the 4th enlargement? So here's our original at enlargement 0, because that's where it started, and this is the 4th enlargement. So we don't have to find the rate of change between every single point, just the ones they're talking about. Whenever you have a table, the top is always x, the bottom is always y. So x1, y1, x2, y2. So I'm going to fill in my formula. 36.6 minus 15 over 4 minus 0. Definitely use your calculator when you're dealing with decimals. 36.6 minus 15. Oops, I'm going to clear my note. 36.6 minus 15. We get 21.6. 4 minus 0 is obviously 4. Our answers are decimals, so I want to make sure I divide that out to see what I get. And I get 5.4, which is choice 3. It should make sense that it's a positive because we went up between the two numbers. Okay, if you go to the next page, the first number 4, I messed up the numbering. The first number 4 is exactly like the problem we just did. You would do it between 20 and 80. You would label them x1, y1, x2, y2. But you can see that one in the filled in notes. Number 4 says a family is traveling from their home to a vacation resort hotel. The table below shows the distance from their home as a function of time. So this is how long they've traveled, and this is how far they are from home. Determine the average rate of change between hour 2 and 7. So I need to use this one and this one. So x1, y1, x2, y2. The big part in this one is including units. So we'll talk about that at the end. So first I'm going to do my formula. So y2 minus y1 over x2 minus x1. 480 minus 140 is 340. 7 minus 2 is 5. If we divide that out, 340 divided by 5, we get 68. Now notice, it's the y's over the x's when you do your formula. y2 minus y1 over x2 minus x1. What do my y's stand for in this problem? What do my x's stand for in this problem? So what that means is 68 miles per hour. So you can leave it like that. They would accept that answer as your units because it's your y's over your x's. You just take that label. Or you could write it as how we know to write it, 68 miles per hour. Either one is fine. If you look up here, your label here would have been millimeters over years. But a lot of the problems don't ask you. You just have to make sure you understand where that comes from. Number 5, you would just pay attention to where they want the rate of change from. So from 3 to 9. So just like we've been doing, you would label them x1, y2, or x1, y1, x2, y2. But you can see that one in the notes. I'm going to skip 6 and 7 because they are just like that one on the front that we did. Number 1, you have to find all of the different interval multiple choice. So this one is from 2002 to 2004, so you would use these 2 points. Then this one is 2003 to 2005, so you would use those 2 points. Same thing down in number 7, you would use 1898 and 1971 and keep going from there. But again, those are both filled in on the filled in notes. 10 is also just like those ones. You want to find the greatest rate of change. It's identical to number 1, so you just have to use those points. But number 8 and 9 are important because they're different. You're not given the graph or the table. You have to find the values that you need. It says an astronaut drops a rock off the edge of a cliff on the moon. The distance, d of t in meters, the rock travels after t seconds can be modeled by the function d of t equals 0.8 t squared. What is the average speed in meters per second of the rock between 5 and 10 seconds after it was dropped? So they give me my x values, that's really x1 and x2, but I don't have the y values that goes with the time it was dropped. Well, what you can do is you can plug x in, or t in this case, into the problem. So I'm going to find d of 5, so I'm going to do 0.8 times 5 squared to get my y value there. And then I'm going to do d of 10, so So I'm going to do 0.8 times 10 squared to get my y value that goes with that one. So in my calculator, and again, just like the other day, you don't have to have a graphing calculator to do these ones. You can type them in piece by piece. So I get 20 there, and then 0.8 times 10 squared, and I get 80 here. So if this is my x1, this would be my y1, 10 is my x2, so this is my y2. So now when I do my slope, I have y2 minus y1 over x2 minus x1. 80 minus 20 is 60. 10 minus 5 is 5. 60 divided by 5 is 12. So 12 is the answer. And then this one would be exactly the same. A population of rabbits in a lab, P of x, can be modeled by this function, where x represents the number of days since the population was first counted. Explain what 20 and 1.104 represent, and then determine to the nearest tenth the average rate of change from day 50 to day 100. So that's x1 and x2. So remember from the notes that we did last week on exponential growth and decay, 20 is our initial amount. And the 1.104, remember what's in parentheses, that is our growth factor. It would be decay factor if it was less than 1, but because it's growing, it's our growth factor. So then you're going to do the same thing over here. We're going to do P of 50 equals 20 times 1.014 raised to the 50. And then you're going to do P of 100 equals 20 times 1.014 raised to the 100. And then you can put them right in your calculator. So 20 times 1.014 raised to the 50, you get 40.08. And then 20 times 1.014 raised to the 100, and we get 80.32. And it says to the nearest tenth, so it's good to always go an extra decimal in the pieces before you're gonna round. So I'm gonna, if this is x1, this has to be y1. If this is x2, this has to be y2. So 80.32 minus 40.08 over 100 minus 50. I definitely would use your calculator. So 80.32 minus 40.08, and we get 40.24, and then 100 minus 50 is 50, and then I'm going to divide that by 50, and we get 0.8048, and it wanted it to the nearest tenth, which remember is 1 decimal, so 0.8 is the answer.